Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as Halogen Derivatives of Alkane. Let's see the chemical reactions of halogenates. Let's see the chemical reactions of halogenates. First is halogenation. Right? Now, what happens when chlorobenzene reacts with chlorine? Chlorobenzene reacts with chlorine. This is chlorobenzene reacts with chlorine. Right? This reacts with chlorine in the presence of ferrous chloride at room temperature and darkness. What you would get here is O dichlorobenzene. You would have this is O dichlorobenzene and P dichlorobenzene. Right? This is ortho dichlorobenzene and this is para dichlorobenzene. Right? So in this case, chlorobenzene undergoes reaction with chlorine in the presence of ferrous chloride to give you ortho and para compounds. Right? Next reaction, let's see nitration. What happens when chlorobenzene reacts with nitric acid? Chlorobenzene with nitric acid, right? Chlorobenzene with nitric acid, HNO3. Now, the reaction takes place in the presence of concentrated sulfuric acid, and heat. Right? What would you get here is that the nitrate compound would be substituted, so you will have benzene, chlorine as it is, so you will have nitro compound that will be substituted here, plus chlorine and nitro compound substituted in the para position, in the ortho and the para position. This is chlorobenzene. This is going to be ortho nitro chlorobenzene, and this is para nitro chlorobenzene. Fine. Next, the third reaction that you have is sulfonation. Sulfonation. In this compound, in this process, it is a process in which the aromatic compound reacts with concentrated sulfuric acid to form again ortho and para sulfonic acids. Similar to the previous two reactions, what happens when chlorobenzene reacts with sulfuric acid, right? Chlorobenzene reacts with sulfuric acid, right? Now the reaction takes place in the presence of heat. You you would get ortho and para compound. So chlorine here as it is, SO3H plus chlorine SO3H, right? This is chlorobenzene. This is going to be your ortho chlorobenzene sulfonic acid, chlorobenzene sulfonic acid, and this is going to be para chlorobenzene sulfonic acid. Next, let us see Friedel-Crafts reaction. Now, Friedel-Crafts reaction when methyl chloride reacts with chlorobenzene in the presence of methyl chloride reacts with chlorobenzene in the presence of anhydrous aluminium chloride. In presence of anhydrous aluminium chloride. Right, let's see this. Chlorobenzene reacts with methyl chloride in the presence of anhydrous aluminium chloride, right? So in that case you will have benzene ring as it is, chlorobenzene as it is. The methyl compound is going to be substituted in the ortho and the para position. So you will have a methyl compound here and you will have methyl compound in the para position. So this is going to be chlorobenzene. This is methyl chloride. This is ortho chloro. Now, methyl group with the benzene ring is called as toluene. And this is para-chlorotoluene. Right? So that is my Friedel-Crafts reaction. Next, let's see reaction with metals. Reaction with metals. Let's see. What happens when bromobenzene reacts with sodium metal? Bromobenzene with sodium metal, right? So you have bromobenzene reacting with active metal sodium, right? Now this is very similar to your Wahl's reaction, right? So you take two molecules of bromobenzene and react with two sodium atoms. So what you will get is the two benzene rings will attach with each other, will get joined to each other, and you will have diphenyl. What you will get is diphenyl. The reaction takes place in the presence of dry ether. Fine, do we get this in here? So this reaction In this reaction, you get diarides are obtained by coupling two aryl halides, right? This reaction is also called as Fittig's reaction. This is called as reaction called as Fittig's reaction. This particular reaction is called as Fittig's reaction. Fine. You could also have a reaction in which you have, say, chlorobenzene with sodium metal and methyl chloride. Right? Now, that particular reaction in which you had an haloarray reacting just with sodium metal was called as Fittig reaction. Here, you have an haloarray reacting with sodium metal and an alkyl halide. Let's see the reaction, guys. What you get here, you want chlorobenzene. This is chlorobenzene, reacts with sodium metal and methyl chloride in the presence of ether. Right? Here, what you will get is the methyl compound will substitute chlorine. You will have CH3 plus you will get sodium chloride, 2Na. So both the chlorines will come in, 2NaCl. Right? So this is your chlorobenzene and this is your toluene. Right? This reaction where you are reacting a chlorobenzene with sodium metal in the presence of an alkyl halide is called as, reaction is known as Fittig's reaction. This reaction is called as a Fittig reaction. Now, next, let us see what are the uses and the environmental effects of alkyl and alkyl halides or alkyl and aryl halides. Uses and environmental effects. Let's take one compound and let's see this. Dichloromethane. Dichloromethane, that is CH2Cl2. Right? Where do I use dichloromethane and what are its environmental hazards? It is used in the manufacture of drugs, paints and paint removers. Used as solvent in drugs, in manufacture of drugs. And paint removers. Right? Then it is used to remove caffeine from tea and coffee. It is used to remove caffeine from tea and coffee. Then dichloromethane, it is also used as aerosol spray propellant. It is used as aerosol spray propellant. Right? Then it is also used as a fumigant pesticide. It is used as fumigant pesticide, and it is also used for metal cleaning. Used for metal cleaning. Right? Those are the uses of dichloromethane. Let's see what are the environmental hazards of it. It harms the human nervous system. It causes nausea, dizziness. It may cause impaired vision, hearing. It may damage the cornea if it comes in contact with the eye. So those are the harmful effects. Harmful effects. The harmful effects of dichloromethane: harms human nervous system. Harms human nervous system. Then causes nausea and dizziness. Causes nausea and dizziness. Then it causes impaired vision and hearing. Causes impaired vision and hearing. Then can damages cornea if it comes in contact with the eye. Damages cornea if it comes in contact with eye. Right? Those are the harmful effects of dichloromethane. Next, let's see trichloromethane. Trichloromethane is also called as chloroform. Trichloromethane, right? Which is also called as chloroform, which is CHCl3. Now, where do I use that? It is used in the production of chlorofluoromethane, which is a refrigerant, which is used as a cooling gas. Then it is also used as a solvent for fats, alkalides. It is used in the pharmaceutical industry. It is used for producing dyes and pesticides. Fine. Uses, it is used in the production. Used in production. Is used in the production of chlorofluoromethane. Chlorofluoromethane. Right? Then, which is a refrigerant. Then it is used as a solvent. In it is used as a solvent for fats, pharmaceutical industry, It is used as a solvent for fats, pharmaceutical industry, and producing dyes and pesticides. Dyes and pesticide. Right? Harmful effects. Chloroform has to be kept in a dark amber colored bottle as it produces toxic gas known as phosgene. Now, exposure to chronic chloroform may cause damage to the liver, kidney. Breathing more amount of chloroform may cause fatigue, dizziness and headache. Right? Harmful effects. Harmful effects of chloroform. It produces It is kept in dark amber colored bottle. It is kept in dark amber colored bottles. It is kept in dark amber colored bottles as it produces toxic phosgene gas. What is phosgene gas? It causes a disease called as phosigor. This particular gas is used as in chemical warfare. Once you have phosigor, your bones of the jaw will not move. You will neither be able to open your jaw nor will you be able to close your jaw. Right? So it produces this toxic phosgene gas. Then besides that, exposure to chronic chloroform may cause damage to liver and kidney. Breathing more amount, that is more than 900 parts of chloroform per million part. Breathing more amount of chloroform may cause fatigue, dizziness and headache. Right? That's regarding your trichloromethane, which is also called as chloroform. Next, let's see another compound. You have tetrachloromethane. You have another compound, read it ABC. Tetrachloromethane. Tetrachloromethane, which is CCl4. Right? Now, it is a colorless volatile liquid having a characteristic odor and it is soluble in air. Now, where do I use tetrachloromethane? It is used as a propellant for aerosol. It is used in the manufacture of refrigerants. It is used in fire extinguishers. It is also used as a cleaning liquid. It is used for dry cleaning. It is used to kill pesticides, insects which are stored in the grains. So those are the uses of tetrachloromethane. What are the harmful effects of this? Same as the other compounds. It causes dizziness, headache, nausea, eye irritation. It damages the nerve cells, causes skin cancer by depleting the ozone layer by getting mixed with air. So those are the harmful effects of tetrachloromethane. Let's write this down. It is a colorless. It is a colorless volatile liquid. It is a colorless volatile liquid having characteristic odor and soluble in air. Right? Used as propellant for aerosols. Then it is also used in the manufacture of refrigerant. Then it is used in fire extinguisher. Used in fire extinguisher. Then used as cleaning fluid. Used as cleaning fluid. Cleaning fluid, it is also used in dry cleaning. Used in dry cleaning. Besides that, it is used to kill, it is used as a pesticide to kill insects in stored grains. Used as pesticide to kill insects in food grain. Right? Harmful effects. Under harmful effects, same causes dizziness, headache, light headache. Then it also causes nausea, vomiting, eye irritation, then damage is nerve cell, right, and can cause skin cancer by depleting ozone layer. Cause skin cancer by depleting ozone layer. Fine, do we get this in here? Okay, the next compound that you have is hydroform. CH3. Now, what is hydroform? Hydroform is a yellow volatile solid used as medicine and healing agent. It has antiseptic property and it is used to dress wounds and sores because of its tendency to liberate iodine. The only harmful environmental effect that it has is that it has a very strong smell. So hydroform is a yellow volatile solid used in medicine as healing agent. Then has antiseptic property. It has antiseptic property and it is used to dress wounds. Right? Why is it used to dress wounds? Because it can liberate iodine. Environmental hazard. It has a strong smell. Right? That's hydroform. Next, we have ferrons. Let's see ferrons. It is CCl2F2, which is nothing but chlorofluoromethane or ethane, collectively are known as ferrons. What are ferrons? Chlorofluoromethane and ethane collectively known as freons or ferrons. Right? Where do I use them? Again, they are used as propellant in aerosol products, foods and cosmetics. They are used as refrigerant and for air conditioning, and they can act as fire extinguisher. Their environmental hazard is that they cause depletion of the ozone layer, right? And in refrigerant, they release propane gas, which is toxic in nature. Fine. Used as propellant in aerosols products. Then used as refrigerant, used for air conditioning. Then can act as fire extinguisher. When will they act as fire extinguishers? When they contain bromine in its molecule. So if they have bromine, then they can act as fire extinguishers. Harmful effect. Harmful effects. Causes depletion of ozone layer. Causes depletion of ozone layer in refrigerant form. And freons form propane, which are toxic in nature. Right? And the last compound that you have is DDT. This is dichloro diphenyl trichloroethane. Dichloro diphenyl trichloroethane. How would the compound look like? Dichloro diphenyl. So first of all, I need to have phenyl group. This is my one chloro. This is one phenyl. I need another phenyl. So that means this is diphenyl, right? Dichloro diphenyl trichloroethane. This is your trichloroethane. That means I need 3 chlorines. Chlorine, chlorine, chlorine. This is how the compound would look like. This is my molecular structure of DDT. Dichloro diphenyl trichloroethane. Right? Now this is a chlorinated organic insecticide. This was discovered by Paul Mueller in 1948. It is the first chlorinated organic. It is the first chlorinated organic insecticide. Was discovered by Paul Mueller in 1948. right? It is used as an insecticide against malaria, and it is also used to kill house flies and mosquito. As an insecticide against malaria. Then due to its toxic effect, it is used to kill housefly and mosquitoes. Harmful effect: it creates an ecological problem as it does not get readily metabolized. If it stays for a long time in the soil, it causes plant and soil pollution. Creates ecological problem. As it is not readily metabolized. Right? So that is your disadvantage of DDT. Right? Okay. We'll stop this here for the day. Thank you very much.